All right, so this is going to be the second video in our series of videos here on flow control. And what I want to do is show you two handy little built-ins that I use a lot when I'm doing flow control, in particular when I'm using for loops. All right, the first is known as the enumerate method. So let me get a list built. So let's say that we have just, again, some characters. Let me keep single quotes there. So I've got a list of characters, just the capital characters A, B, C, and D. All right. Now, a lot of times we've already seen how we could say, well, okay, so this is going to be for character in my list. And we could do something like print character. All right, and we can do this and we can print, but sometimes what we also want, in addition to actually the item that's in the list, and this will especially be true if we've got some other type of flow control like if statements that are looking for a special condition or whatnot, we might want to know, well, not only when that condition is satisfied, but also at what position in the list or the thing that we're iterating over, is it satisfied, right? So we want to maybe know the index, or maybe we're wanting to print off, the list with, okay, kind of in a pretty format where we've got first item, second item, third item, so forth. So we don't just want the list back, we need some information about position in the thing that we're iterating over. All right, and that's where enumerate comes in. All right, so first off, if I were to look at enumerate, so this is a built-in, let's just get the type of it. Let's look at the type of enumerate. All right, so it seems that most of these built-in functions are just returning the type of type. All right, so it's a built-in function. All right, and let's look at its signature. So I'm just going to open a left parenthesis, hold down Shift, and hit Tab. All right, so what does it take? So here's its signature. So enumerate, you provide it an iterable, and then you give it a start argument. If you provide no explicit start value, it's going to default to 0. All right, so that's what that equals 0 is telling us. So let's look at what it does. So it yields pairs containing a count from start and a value yielded by the argument. So it's going to return to us two things. It's returning pairs. One of those is a count from whatever the start is, and then the value. All right, so if I were to put my list in, let's just see what happens. All right, so I'm not going to do anything. I wanted to use the default start value. All right, so it returns this weird kind of thing. So we might expect that it's actually going to print something to screen, but it doesn't. It's actually printing out, it's saying, hey, this enumerate object, and what this is actually doing is it's pointing to a memory address on your machine. So it says, hey, here's an enumerate object at this particular location. All right, well, let's just put it in a for loop and let's see what happens. So I'm going to do for, and I'm just going to put an underscore right now because I'm just doing this as a temporary variable and I want to see what that is actually returning. So let's print that temporary variable underscore. So we see that it's printing 0, 1. So it's returning a tuple, a pair in this case, of two elements. 0 and A, 1B, 2C, 3D. And notice that since it starts at 0 and we're iterating over this list, that, okay, these numbers correspond to the index position for each one of these values in the list that we're iterating over, right? So if I were to go to my list and grab the value at index position 2, right? So that's actually the third thing in there because we start indexing at 0. All right, we get C back, right? So that 2 is telling me, hey, C is located at 2. All right, so this is returning us two things, right? So we can actually use that multiple assignment instead of assigning it to underscore. I can say, well, this is going to return to me a pair, two things. The first of those is going to be the index. I'm just going to call that IDX. All right, and then it's going to be my character. All right, and now what I'm going to do is I'm going to print. And let's make it an F string. Let's say, okay, do that. And I'm going to say character is at position index or IDX. All right, so now we can get information about where that is. And that's all because that start is at 0 and the indexing of a Python list, or a Python iterable in general is going to start at 0. All right, so enumerate's really helpful. Now, what if we wanted to get, like I said, that pretty, element 1? Because again, a lot of times if we're trying to print something out, maybe we're writing it to a file or something like that, and we can use a for loop to automate that. We don't want things to start at 0, right? Maybe we want everything to start from 1, right? Which is very common when we're doing listing. All right, well, we can change that. All right, so what I'm going to do, instead of copy and paste, I'll do it all. So I can say for index character in enumerate my list. All right. And instead of starting at 0, what I'm going to do is say start equals 1. All right. And what we'll do is we'll print, let's print the index IDX. And then I'll do a period after that, and I'll print our character. All right, so now we've got a list that starts from 1. If we wanted that to start from 2, right, we just change our start parameter. If we want to start from 100, there we go. All right, and you actually don't have to explicitly say start equals. I'm going to hold down Shift and hit Tab in that enumerate call. So in this case, this function is taking 2 arguments. The first should be an iterable object, and the second is going to be the value for start. So if you just provide something like this, Python's going to assume, well, the first thing in that you're passing to me should be the iterable, and the second thing should be your start, and this will actually work exactly the same. All right, so that's enumerate. That's very helpful because a lot of times we do want to kind of get back that index. And now we're going to look at another very, very helpful built-in called zip. All right, and we kind of run into this a lot of times. So we might be, reading in different types of data, and we've got particular 2 different objects or 2 different variables in our Python program that are they're essentially matched, right? So the first element in each one of the items are corresponding to one another, but they're not in the same object. You might have, one list that's storing ages, one list that's storing names, one list that's storing addresses, and they're, essentially oriented such that, element-wise, they're all corresponding to the same entity, but you just happen to have them in different objects. Now, of course, we're going to see in future videos, we'll look at, different ways of handling this, because I would say that, the majority of time when you're working with data, you're not going to use different objects to kind of store your data and try to do that bookkeeping between them. You might use a different data structure altogether, and there'll be some videos that look at different data structures, but it does happen, right? And so what if you've got these 2 objects and they should kind of correspond to one another element wise, and you need to print out entries from them as pairs? All right, so let's actually look at this, right? So, and let's look at 2 different solutions for it. So let's say we've got some names here. We got Alice, got Bob, got Carl. All right, so that's our first object. And let's say that we've got some ages. All right, and let's say that we've got 42, 54, 26. All right, so this is the situation that I was talking about. So I've got one list here. So my names, I spelled Alice wrong. Let me respell Alice. All right, so we've got our names and our ages. Let me do a kernel restart, clear all outputs, get everything nice and clean from the top. After fat fingering Alice. There we go. All right, so we've got 2 objects, names and ages. Both are lists, and they both have 3 elements, right? So Alice, Bob, and Carl, 42, 54, 26. And let's assume that, this is our situation, and the ages correspond in a kind of an element-wise fashion to the names. In particular, Alice is 42, Bob is 54, and Carl is 26. And we want to print out or iterate over these objects, matching up those pairs. All right. Well, here's one way that you could do it using the enumerate function, which we just learned. All right. So what we could do is we could just say, well, okay, well, for name, or let's do for index name in names. And what we want to do is we want to enumerate names starting at 0, because that's going to be your 0 index for Alice and 42. And then what we'll do is we'll say, well, age is going to be equal to ages for whatever the current index is. All right. And then we can print something like this. We'll say name is age years old. All right, so this works. Okay, so we can use enumerate, and as I'm iterating over those names, I can get the index back, and then I can look up the value for that same index in our ages list and print that out. So this is perfectly fine. This works. The challenge with this, the issue with this, is it's not as readable as it could be, right? So it's kind of odd. Right? We get this index back, and then we're going back and we're grabbing, the ages value at that index position, and then we're printing them both out, right? So it's not horribly, complicated, not too challenging to kind of understand. But again, to a new programmer, or even yourself, 3 months after you've written the code and you had to go back and make some type of change, it's going to take you a second to kind of get up to speed and kind of remember what that is, because we're using this index and we're kind of passing it around. It's just not as readable, not as intuitive as we would like it to be. Although it's completely, it functions, right? It's working. All right. Well, what could we do instead? All right. So I'm just going to bring this list down. I'm going to copy them again. All right. What you can do is you can use this zip function, or this zip built in. So zip, let's just look at it. If I open the parenthesis there, hold down Shift Tab, what it does is notice here in its doc string, it's saying, well, it's taking star iterables. And what that's telling us is it can take just a bunch of different iterables, right? So you can give it several iterables. And what it's going to do is it's going to yield tuples. Okay, so in length tuples, where n is the number of iterables passed as positional arguments to zip. All right, so the ith element comes from the ith iterable. So if you give it multiple iterables, it's just going to go through those indices, and it's going to return the value from all of those iterables at that index position. All right, so let's look at this. All right, so again, just like I did with enumerate, I want to kind of get a better understanding of what's going on. So I'm going to say for underscore in zip names and ages. All right, and then let's print underscore. All right, so we gave it names first, we gave it ages next. Notice that what it's doing is it's returning tuples. So it's paired Alice with 42, Bob with 54, Carl with 26. So it's returning to us those pairs. It's essentially just iterating through each and saying, well, okay, you gave me 2 iterables, so I'm going to return a 2 tuple. So a tuple with 2 elements, essentially a pair, where the first element comes from the first iterable and the second element's coming from the second iterable, and so on. Right, so it's giving me back names and age. So I can say, well, now for name and age, since it's giving me back 2 things, I can have 2 loop variables. And then I can do that same print statement. I'll save a little bit of time right here and just print that. All right. And to me, again, if you're looking at comparing this code where we're using that index from enumerate, which again, enumerate is a brilliant function. It definitely has some use cases that are it makes life a lot easier. But in this case, right, since we're wanting to zip them together, right, we could just do it all in one go. All right. One thing that I will show at this point is the interesting thing, or one thing that's challenging, or you got to be aware of, I should say, is let's say that we had, for some reason, right, we had more entries in our names, right? So we got 4 entries in our names list, and we only got 3 in our ages. All right, so when it gets to Devin, it's not going to have a matching pair in ages. Well, what zip's going to do is zip is just going to, by default, it's going to stop at the shortest index position where it has entries in all of your iterables. So we can see the result is exactly the same as it was before. It just skips Devin, right? Because why? Because when it looked at the index in the second iterable, ages, it couldn't find a corresponding entry, right? And the same thing would happen if we had more ages, right? So if I put, 50 right here, so we got 4 ages and only 3 names, it's still going to stop. So that's the one thing that you've got to note is, and this is kind of the one challenge. And again, this is kind of why there might be some better data structures. Not to say that there aren't valid use cases that you will use zip and enumerate. I use them all the time. But again, in this case where we've got to make sure that we have entries for each, because you might iterate through and you say, oh, well, here's all our names. Well, a minute ago we had Devin there. What happened to Devin, right? We might have just not had an age value for him. And what happens if, for some reason somebody doesn't have an age and, it gets returned as this, right? So maybe Bob didn't have an age and it just returned nothing in your list. Well, now it's associating Alice 42 and Bob with 26, where Bob really in reality might not have had something, and that's Carl's age. So you got to be careful. But again, still some very valid use cases. All right, so let me get my age back in there for Bob. And let's just look at the case where we have more than 2 things. All right, so I'm just going to copy this down below. And let's just say, so we got our age, and then let's just say height. All right, so let's just maybe do, height in inches or something like that. So let's just say 70, 72, 56. I don't know. Might be so short. All right. So now we've got 3, name, age, and height. So we can actually pass in 3 iterables. So I can pass in my height. Now notice I'm going to run this. This is going to give me an error. And so in this case, we got 3 iterables. It gives me an error. It says, hey, there's too many values to unpack. I expected 2. Well, what does this mean? Well, notice you got 3 iterables. If you ever run into something like this, you can always, again, just go back and say, well, you know what? I'm just going to make this an underscore. I'm going to comment out this line using the pound sign, and I'm just going to print whatever's going on with underscore. Right? So I'm saying pack it all in there. Well, here it is. We gave it 3 iterables, so now it's returning a tuple with 3 elements, right? Alice, age, and height. So instead of having 2 variables over here, right, we got to have 3. And let me make this heights. There we go. Fantastic. All right, so I'm going to undo that, and then I'm going to take out my... So they are age years old and height inches tall. Fantastic. So that's enumerate and zip. Again, those are extremely handy. I do use them all the time. Of course, there's caveats with both. In particular with zip, you've got to make sure that there aren't cases where the length of the various iterables that you're passing could be different. Otherwise, you can have some unintended behavior happen. But we will, of course, in other videos later on be looking at different data structures, or maybe even in a different playlist. I'm thinking of more tabular type of data structures where we can associate entries for an individual or some type of entity on like a row. And that, something like a pandas or a polar. So there'll be playlists looking at those as well. But again, there's going to be a lot of use cases where these come in handy. So there they are.